TU Delft's Delta Infrastructure and Mobility Initiative stimulates interdisciplinary work on the reconstruction of infrastructure in urban deltas. Reconstruction of Uriage after the 2011 tsunami was investigated by a group of students and staff from 5 disciplines: hydraulic engineering, geotechnical engineering, water management, transport and planning, and urbanism. Uriage is in Tohoku, Japan, a region prone to frequent large earthquakes and tsunamis, and that has been struggling with the shrinking and aging population together with a declining economy for the last several decades. The reconstruction consists of the building of a coastal dike, which is the first line of tsunami defence, where also, through the implementation of spatial planning, residents were relocated from hazardous areas. The only rebuilding near the coast was for industries related to the fishing port. Further inland, dikes were under construction along a canal to serve as a second line of defence against large tsunamis. The new residential area under construction further inland was made safe by elevating it by metres of land-filled earth. Public housing blocks doubled as vertical evacuation structures, whilst roads were designed to provide a straight route for horizontal evacuation. By understanding, analysing and discussing the scope of reconstruction solutions from the point of view of each discipline, as well as in a team consisting of all 5 disciplines, methods for interdisciplinary working were tested, learned and experienced, and Japanese resilient solutions were applied to the Dutch case. The project involved 2 groups of students, an interdisciplinary project group and a group of thesis students. The big picture of the project was addressed by the interdisciplinary group in 3 phases: analysis, synthesis, and design. In the first 2 phases, the case of Uriage was the starting point, whilst in the design phase, what was learned and designed there was transferred to the Dutch city of Vlissingen. After preparation in Delft, a group workshop held at Tohoku University aimed to study how the reconstruction of Uriage was planned and implemented, and to understand where different reconstruction methods are positioned through a charrette method. This interdisciplinary scope of possibilities is built up from the scopes of disciplinary possibilities that are brought together in the charrette. After multiple rounds of discussion, the groups generated frameworks showing the linkages among the disciplinary scopes, which enabled the students to analyse relations among disciplinary decisions and to explain and assess the case from an interdisciplinary viewpoint. The frameworks were the base for spatial designs. Group A created a master plan for Uriage based on 5 design criteria. These balance out multi-purpose and nature-based urban design with engineering intervention. Group B focused their design on using a dune and dike solution near the shore, where the dune system also functions as the base for a coastal forest, which is a traditional Japanese tsunami protection technique. The lessons learned from the tsunami reconstruction process in Uriage were then applied to the Dutch context. Vlissingen was chosen because of its comparable location, demographics and economic issues. To build back better, the whole group of students formulated 2 designs. Both incorporated multiple lines of defence as learned from Uriage. Coastal dunes and dikes were combined with parking structures and promenades. Further inland, residential areas were physically elevated in one design, and in the other were combined with canals dug to lead floodwaters from storm surge or heavy rainfall to a sunken polder outside the city core. Road and rail transport arteries were designed to incorporate use for both daily life and evacuation. These proposals were elaborated on by the interdisciplinary project group in an iterative process in which they would develop their parts separately and bring it together again in 2 steps. In addition to the big picture and detailed designs for Vlissingen, the group of MSc thesis students developed their individual thesis that addressed disciplinary topics in detail, but in the context of the other disciplines. To make the tsunami reconstruction of Tohoku more resilient, the Dutch approach of regional design is tested. This approach balances out the local qualities on the larger scale and reinforces them on the smaller scale. For this scale, 3 urban designs are made. for a tsunami mitigating riverbed, renewable energy plan, and the development of a transit-oriented design location. The TOD is part of the transport and planning thesis, in which a regional transport design is made to respond to demographic changes of a shrinking and ageing society. Using a demand, transport and land use feedback circle, the design also integrates land use planning into the transport system, with the goal to be able to face an uncertain future with economic, social and environmental shifts. The geoengineering project focused on the stability of geotextile reinforced slopes, with Uriage raised area as the case study. Two methods were used for analysis, first using limit equilibrium method and second using finite element method. In Japan, a lot of concrete is used, and the application of geotextile could make these spaces less steep and multifunctional for ecological and recreational use. The geotextile is also applied in the urbanism thesis, which takes the reconstruction of Uriage to the level of modern urban renewal. This includes topics of water management and energy, and includes the introduction of spatial quality. To be able to qualitatively assess the tsunami resilience of a transport system, the first step is to deconstruct this concept into determining factors of tsunami resilience. This forms an assessment matrix that is also tested on Oahu, the most urban Hawaiian island. The last project uses hydraulic engineering experiments and simulations of tsunami shoaling and run-up to optimize the effectiveness of coastal dikes and seawalls in mitigating tsunami damage. The project as a whole delivered a lot of knowledge about resilient design and how land use segregation, multiple lines of defense, and hard engineering methods from Japan could be merged with Dutch ideas of building with nature and multifunctional flood defense. The group also trained in the interdisciplinary approach and discovered how the 5 disciplines can interact, especially by doing the same process for 2 locations. To be able to interact on a deep level, it turned out that scoping per discipline really improved the exchange of ideas in discussion and brings a solid base for the design of future resilient cities.